Hello, all. Today's topic is about structures, unions, and enumerations. We see couple of topics inside in this structure, unions, and enumeration. First, we'll go with how to define and use these structures, and then after that, we'll see how to declare an arrays within a structure and how these structures can be passed to the function. And structures and unions are the same side of things, but will have very minute changes in each of these functionalities. We'll see how these unions be defined and usage of these unions. And finally, we'll understand what is enums, which is enumeration, and how these bit fields can vary within the structure and the unions. How we can tackle with it. This bit fields purely depends on the register, which is stored, secured way of running the program. Let's start with defining an usage of structures. In C programming, struct means a structure is a collection of variables. This collection of variables can be with the same data type or different data type as well. So these all variables can be present under same structure with a single name. Now we can use an example. Example is we can use either a character variable, int variable, float variable, or array variable. It can be anything. It doesn't mean that if you use an integer inside the structure, all the variables inside the structure should hold only integers. That is not the right way. You can create only integers, can create only float, only character, or mix of those. That is also possible. Before you create a structural variable, right, you need to define the data type of it. The data type, to define the data type, struct keyword is a data type of structure. So every structure name should be preceded with struct. So the syntax of it is struct and the structure name followed by curly braces, data type of the particular variable 1, data type of the particular variable 2, and so on. At the end, you have to stop with a colon. Now, for example, a struct. I have created a struct. Structure name is person. What are the variables inside it? Char, data type char of his name. Size of it is 50. It's an array of 50. His name is a character array. Now, int city number, float salary. What is his salary? So these three will be different parameters or different variables that holds for a particular structure name called person. Now, how to create a structure variable? When a struct type is declared, no storage or memory gets allocated. Let's say you have created like this structure person and there is nothing inside it. That means if you are not giving any of the variables inside this structure, then compiler don't know how you have handled, going to handle, and how much memory is needed for your execution. For due to which it doesn't know how much size you want to allocate for this particular structure. So when you just create the structure and doesn't include any variables in it, then it won't allocate any storage to it until unless you specifically declare the members of our structures, then only it gets allocated. To allocate the memory, right, you need to give in a structure type and how to work it with the variables. So these are the several types how to do it. Struct, keyword, and person. With anything, without any declaration also you can declare. Another format of doing it is you have declared here, but the variables you can declare inside the main function as well. So int main function struct person is, this person is a structure name, and corresponding variables associated to the structure are person1, person2, and p of 20. Now return 0. The same way can we do it another format also. Struct person structure name, and at the end, right, you can associate the variables like this as well, which is person1 comma person2 comma p20, which is an array. Now how to access a member of a structure? You are declaring it, but how to access it? So there are two types of operators which is used to access the structure members. One is member operator, second is structure pointer operator. Now we use another keyword called typedef in structures. So what is this meant by typedef? This typedef keyword to create alias name for the different data types. Alias name means, let's say you have given with one name. The same name cannot be used everywhere in the structure. For that purpose, instead of writing the name for it, you will create a short name for it. That is a structural name itself. So how to declare this? How to use this? A simple example. The typedef is a keyword which used to create alias name for these data types. Now typedef, and as we used for this structure, right? So structure keyword is also needed, and structure name. Structure name is distance, capital DISTANC, distance. Now this is a structure name. Inside it variable int feet float inch, and at the end you wrote here as a distance. So this is not another structure variable. This is the typedef alias name. So whenever you want to, use this structure, you just use the distances alias name. It indirectly uses the structure name over here, distance. Now some of the usage examples we'll see, out of which one is this particular code. So stdio.h printf scanf things, string.h for string copy functions. I will use string.h utility. Now I am creating one structure with the name person in it. So it has three different variables, structure variables. One is character name array with 50 size, init city number, float salary, and structure variable is person1. Now in the main function, I assign the value of the person1 name as using string copy. String copy, what it does is it just copies the value to the assigned variable. That's it. So the person1 is a name of a structure person. In that, as we see how to access the variable of a structure using dot operator. This is the dot. Using this dot, you will access the structure members. So the structure member name is one more thing, right? So person1 dot name comma whatever name you can keep. Just copies the data. Another way of doing it is person1 dot city number, person1 dot salary. This is how you will assign values to the structure members. This is how we can assign values to the structure members. For example, you can declare one more thing here. So person here, person is there and person one is there. Instead of person one, I can use person one comma person two. Now what will happen? I will have two different structure members present inside this. So person two is P2 dot name of that person is given with one more array. So that particular name is equal to, let's say his name is C. You can just keep C. Now you can give city number, say salary for this particular person, whatever you need. Then if you want to print the respective person's values, then what you have to do, you have to structure accessing particular member, which is person one dot name. Person one is a structure first member, and this is a variable, name variable. So as this is a character array, so I have to use data identifier as data format identifier as percentage yes. Now next one is, what is a city number? City number is citizenship number. So what is that? I will use D because it's an integer. So it's D. Next one is float. The salary is float. So F dot 2. Here I have used an interesting thing which is dot 2. Dot 2 represents the number of digits that are needed after point. Point means decimal. After decimal point, how many digits you need? That represents point 2. So what I'm saying here, if you see, right, the output gets printed like this. The name George Orwell, citizenship number is 1984, and salary is 25,000. Initially we assigned with 25,000, so 2500. Now as we consider the float as 0.2, that means after decimal we need two digits to be used. That is the reason we have used 0.00. So the same way for C, another person P2, the name of it is C, citizenship number is 1, and salary is 2.5 lakhs. So once you print it, right, 2.5 lakh will come as 2.50 L. Like this, you will get the answer. Next example is, we created a structure and number is a structure number. Now, inside this structure, we are having another structure with a complex number as com. That's a alias name. Now, another variable is int integer. The name of it is number one. So when you go into the main function, we can initialize the complex variables. Complex variables, you know, right? Real number plus imaginary number, I with j. So let's say the real number, imaginary number plus j. Example, 2 plus real number is 2, imaginary number is 3i, and I or j it will come. Okay. This is one thing. Another one is 2 minus 3i. So your real part is 2 and imaginary part is minus 3. So like that. So if you see right here, the number one, the structure in that, the component of imaginary part is 11. Number one component real part is 5.25. And you have assigned an integer to it again. Number one dot integer is 6. If you want to print this data, just you can print using imaginary part is number one dot comp dot image. So if you understand here, right, number one is a structure name of this. Comp is nothing but the alias name of this complex. In this complex, we are using two another variables, which is imaginary number and real number. This is how we are initializing the complex numbers. Now, structure of structure, this is another way of defining. Structure can hold different types of variables. Structure is also a variable, right? That is why it is holds good here. Okay. Now the number one component, complex number image, number one complex number real. So imaginary number and real number. So you can print it as per the need. Now another one number, another number is an integer. So integer. This is how it gets printed. And this is a format identifier point percentage D and percentage point two F and percentage D again. So this is structure of structures. Now, big question will come, right? Why we need structures in C? Let's take an example. With an example, I'm explaining why we need structures in C. Suppose you want to store some information about a person, his name, citizenship, numbers, and salary. You can create different variable names. Let's say in your society, you are having society or colony, you are having 1,000 people. So 1,000 people will have 1,000 different names, and their citizenship numbers and the salaries are different. You can store it. What if you want to store for one more than one person? In your society, you are having 1,000 persons, right? So for this 1,000 persons, you need 1,000 into three. Three variables we are storing for every person, right? So 3,000 variables are needed to store every person information. So which is very difficult, right? So these are all data gets allocated, and to process these 3,000 variables, it takes time to run the program. So that's the reason we need an intelligent solution which helps us to remove this duplicate of creating variables again and again and again. This will be done using structures. So you just create the schema of the particular person, like the struct of the name, let's say the person P, and in it you just create what is the name and what is the citizenship and what is the salary. This is person structure. Okay, alias name is P. If you just create this and rest all is done, you can add n number of members associated to it. And number of members associated to it. So what will happen here is the first person, let's say first person P1 will have corresponding NCS, name, citizenship, and salary directly linked to it. How you will access P1 dot N, P1 dot C, citizenship, P1 dot S, salary. Now for second person P2, the same image gets been taken, and P2 dot N, name, P2 dot citizenship, and P2 dot salary. Like this, you can create all 1,000 people's data using these simple three variables, which is structure variables. Then and there, when you create it, then only the memory allocation will take place. If you're not creating, you just have 40 people join and 60 people are not joined in your colony or a society, then rest 60 people memory allocation won't be done unless the variable initialization happens, then only the memory allocation will take place. Okay, next one is array of structures. When you deal with the large set of relationship data, right, then and different data types are there, to organize and manage it, it is very efficient and crucial. Let's say a person Aadhaar card. Your Aadhaar card will have several parameters, right? Your name, your father name, mobile number, address, age, and so on. These are all details associated to one particular entity of the person. Like that, you in India, we are having so many people. So these all millions and trillions peoples are there. These people's data should be handled and stored very effectively, right? And we cannot tamper like a person one's data when it is retrieved from the server. His data is not coming, another person data is coming, or it is a mismatch. thing is happening. Name of the person is same, but age is coming from some other person. Age is so for that particular time, right? We are storing huge data. To store this huge data and organize this data effectively, we need some concept called arrays in structures. In C programming, right, we can achieve this combination of having arrays in a structure. This arrays in a structure provides a powerful tool to manage it. An array whose elements are of type structure is called array of structure. In general, we use multiple structure variables in our program, like having multiple variables declared in the same structure. Like that, instead of variables, we declare arrays in it. So one of the example, the usage is, sample code of it is, the structure employee has the variables character name 20, integer employee ID, and weekly attendance every week, whether he is present or not. That attendance will be there. This is how you declare array of structure of that particular employee. So structure, struct your employee structure name and employee size is 5. This is how you can create array of structures. For first employee, these are all variables gets declared. For the second employee, again, these variables get declared. Third employee, same, 4, 5, 6, and so on. How many members you are having in your company, you can create those many employees data. Now, how to add or access, assign the values to these members of the employees. So this is how you have to do it. Using for loop I'm doing here. I'm using an I integer I is equal to 0, and I am having the size of member in my company is 5, right? These 5 people. Now I less than 5. That means 0 to 4. 0, 1, 2, 3, 4. So 5 members will come, and the post increment. Now how am I accessing the data is very important. So employee ID of I. So I is 0, right? So employee 0. His employee ID is I. Okay, that means employee array structure, in that again the employee ID. So with the dot operator, I am accessing the first member employee ID using I. Now again the first member's name. How I can access the first member employee ID? Array of employee ID of 0, which is I, increment I, right? Now in the first time it will be 0. So dot operator of the first array element name, which is Amit. And integer is week. For every week, again, if you see here, the first member has again an array of 7 days in this. So to access every day's data, again you have to use a for loop to access everyday data. So as a for loop, and week is equal to 0 and week less than 7. So 0 to 6 and week plus plus. So I'm declaring one temporary variable attendance. So the first employee's assignment and his attendance for that week is equal to 0. So very simple. So how this looks like? This looks like, so if you consider your employee's data as employee 1, first employee, that particular employee will have accessing the data. Let's say your employee 1 will have this particular data. The name as employee 1's name is equal to Amit. And his week number, every week attendance is how much? So for Monday, he is pass 0, 1, 2, 3, 4, 5, and 6th. So for Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. And his ID is what? 0 we have declared. And this is the data associated to employee 1. Now the same with employee 2. I'll use the same. Another person name is, let's say, another person is previously, another person name is, let's say, Prakash. So the Prakash employee 2 is Prakash. So name of his is Prakash. Okay. Name is equal to. Now whether his ID becomes ID is equal to, he's a second employee, right? So ID becomes 1. Now attendance for that particular week is again 0, 1, 2, 3, 4, 5, and 6. Okay. This is how the employee 2 gets created. Till how many? Till my employee 5. So for fifth employee, employee 5 will be the data which is associated to how it's get created. His name, again, his name will come, right? So his name is N is equal to his name. Let's say his name is Sai. So his name will come and his ID is, so we are incrementing till 4. ID is 4. And again, attendance for that particular week is 0, 1, 2, 3, 4, and 5. This is how it gets created. Okay. And how you are doing it is very important. That my application is asking to store this data one by one, which is having internally a loop of weekdays and again every loop of structure. So that is how individually it gets created. You'll get one question here. Character name, the name of a person is an character array and it's an array also, right? Why I'm not using for loop for this array for name? Very simple. Why I'm not using is I am using here string copy. This string copy inbuilt function, what it does is it has an inbuilt for loop. It assigns every point A and stores to it B and stores to it. It's like, let's say how it works. I'll explain you here. Your name is Amit. Okay. How it does is basically this string pointer initially creates empty array. In that it first appends A inside it. Then after second iteration of for loop, then it appends B M into it. So it add M into it. Next appends I in it, which is A M I. Next T in it. So A M I T. This together is called a character array. So this all computation, this whatever computation has done over here, this will be done by string copy. This is an inbuilt function, right? So it take care all this appending. So once you have done and prepared this data, I am printing out the data. How I am printing out the data? Using for loop again. Integer I is equal to 0 to till 5, which means 0 to 4. Okay. So every employee and corresponding employee name. So an employee name and his attendance to throughout the week. Using again for loop, I have to take the attendance toward the week and I print it. So again, why I'm taking attendance for loop? Reason is you will have again 7. If you are not considering for loop, what will happen is if you print like attendance, it will print everything like this together. I don't want that. Every week, what is as attendance? That attendance gets printed one by one. If it is needed, then you have to use for loop. Okay. So let's move to the next one. Passing structures to a function. How we need to pass structure to a function. So we declare a structure called student and the name and age as a variables. So we have a function return for this, which is a display function. It's a void. It won't return anything. And it takes a input argument, a structure. Structure student. S is a alias name. So S it takes. Now let's take main function and see what it written over here. Now structure student S1. I created the alias name for the student S1, one particular student object. Now in this I'm printing what is enter name. So user will enter what is his name? Bond. If user enters Bond, then what will happen? It's a string, right? So character array. So I will store and keep inside the character array. So S1, the alias name of S1 dot name. I will store it inside it. After that, I will ask to give age. Age is 13. Now, you after entering 13 by user, it should store in the age parameter. Now, in the age, the S1 dot age, you have to use it. Okay, to scan the data. Now, display S1. What is meant by that? I am calling a function by passing a structure as an argument. Now S1 is prepared already. What S1 holds? Basically, what S1 holds here? So S1 holds the name called bond, and S1 holds again age. Age is 13. This structure value I am passing into the function called display. What will happen now? Compiler will do the function call. The function definition is defined over here. It jumps from this line to this line and pass the S1 structure to it. Now, once it is passed, what it is doing here is just printing the passed structure argument here by displaying information. And name is Bond, age is 13. This is how we will use to pass structure to a function. So once you create a structure, then that structure only you will pass from one entity to the another entity. How initially one structure is created, the alias name of structure is S1. Then in that S1, we are asking user to provide the inputs. One is born and 13. Then once it is done, then you will scanf. Scanf means you will assign to this particular address, right? So that name you will pass. Once that is done, age also you will pass. Then to display this, whatever information is passed, you use a display function by passing this structure argument to it. So once you pass the structure as an argument, so display function call will happen. The display function is there. In that, what is the argument it takes? It takes just a structure, doesn't take anything. So the short name structure student, yes, short name is yes. So the S1 and S matches. So it takes the information and it prints the names. So S1 will be converted to S. So S dot age will be printed as bond and age as 13. Okay. So the next one is return structure from a function. So how to do it? So previously we are passing structure to a function. That means we are passing argument to a function. Now this is different. This is returning structure to a function. Now once the function is called, whatever the instruction is made in the function, at the end you need to return structure once the function exit. So let's see how it happens. Now we will take a student structure with variable name and age. Again, the same thing, function. we can use a function to declare one function. Second, yeah, to declare a function. That function is name with function argument. Now in that, get information is a function. If you consider this, right, this function type is, we want to return a function, right? Return a structure from a function, right? For that purpose, the return type should be structure. That is the reason we have given here struct. Every structure will have structure name, right? That is why structure name is student. As the structure is not a structure variable, it holds a function. That's why we have given with here a function called get information. So this is how we declare a function which returns a structure. Struct student and get information. Once we go to the main function, create a short alias for the student s. S is equal to get information. Very simple. We just called one function get information. It doesn't need any argument. Now function call will happen. So it sees compiler will jump from here to here. The definition of function over here. Now struct student get information. Return type is structure. So it should return a structure here. Now struct student s1. So struct student s1 is a structure that is getting created here. So it's an alias s1. So where is the definition of the student? Student definition again points to here, this. And it has two variables, name and age. So struct student s1. The short name alias name is s1. Now we will ask user to input it. So user inputs name as Sai. So name s1 dot name is Sai now. S1 structure will have name as Sai and age is 20. Now this structure S1 returns after executing this function. Now S1 gets returned and assigned to S here. So S1 will be assigned to S. Now this S dot name, which is Sai, gets printed over here, and S dot age, which is 20, get printed over here. And at the end, it's a return 0 because it's an integer return type. Return type of function is integer. So this is how we can return a structure from a function as well. So from the function, you can accept a structure while executing the function, or from the function, once it is executed, you can return a function to a member. Now, during this example, right, we should observe two things. One is one is one is you have to understand how this function call happens. So this function, while declaring, you have to declare in a proper prototype. So structure, student, and get information. Very important thing, why I can just mention struct and get information, right? Why I have mentioned student explicitly. There is a reason to do that. One is I want to make use of the structural properties of a student, and at the end of this function, I need to return the structure variable as the same as function of the student. So that is the reason we have used student over here, right? That is one thing. And second thing, to inherit the property of the student, so we have used here student alias name as s1. Once we get the inputs from the user, we take the inputs and store in the structure name and structure age. When that is done, we will pass this to variable s and we'll print this data, whatever it is inputted. Now again, passing structure by reference. We can also pass struct by reference. In similar way, you pass variable by built-in type of reference. So how we do it? During pass of reference, right, the memory address of the structural variable can be passed into the function. So if you see, reference is nothing but wherever reference term comes in C, we pass address. Address means, if you remember, a pointer. Pointer always point to the address of a variable. So that is a reference. Address is a reference. So how we do this actually? How we do this actually? Now, the type def of structure and this complex, the structure name is complex. So the float real and float imaginary, and the structure percentage is complex. So this is the variable name wherein which it is associated. Now another function which is void add numbers. Add numbers is the function that is associated. It takes some arguments which is complex C1, complex C2 and complex star result. What is this complex here? This complex is the alias name for this structure. So it takes an arguments of three different types of structures. Structure C1, structure C2 and the pointer reference of the result. This is the reference which is created for this structure. This reference acts as an address to the structure member. How this can be handled? Let's see further. So in the main function, when we go inside the main function, so the complex is nothing but alias name of the structure, and I'm creating three different structures here. One is C1, C2 and result. C1, C2 and the result. C1 is for the three people, three structure members, we need to create data. So that data we are asking from the user. First one, for the first number, enter the real part, enter the imaginary part. For the second number, enter the real part, enter the imaginary part. Once it is entered, how we are storing C1 data, we'll see. So for C1, what kind of variables can be declared? So real part, imaginary part, because as it is a structure complex, so complex structure has two variables, real and imaginary. For this real numbers and imaginary numbers, so C1 will have C1 dot real, as it is structure. So it has two variables, right? So one part of the variable is real part is 1.1 and the imaginary part is minus 2.4. In the same way, we need to extract the data from second one. Second one also, C2 dot real 3.4, C2 dot imaginary minus 3.2. Once that is done, we will call a function here, add numbers. Add numbers is addition of these two numbers, and it will result to the history. So if you observe here, the argument takes three structures. Structure 1 C1, structure 2 C2 and result structure. So C1, C2 ampersand result. When you pass the function, the compiler will go to the function declaration over here. So if you see right, result, this is a accessing the structure member, the real part, the result real part. Result is again a structure. This is how we use passing structure by reference. So reference is nothing but address of variable, which is a pointer, right? That's why we are used here pointer. So this result tells that we need to add the real part of the both and imaginary part of the both of C1 and C2. So C1 dot real, C2 dot real, C1 dot imaginary and C2 dot imaginary. Dot operator used to access the structure members. That is how we used to access the structure members and assign the values to it. Once it is accessed, we use addition, both addition, and stores that data in referenced part of the variable real, referenced part of the variable imaginary. That is why there are two, as in previous slides I said, we have two ways to access a member. One is dot operator, one is this. Okay. So to show the difference, To show the difference, I have used here this operator. So we can use either same result dot real also here. Instead of this, we can use dot also. But to show the difference, I have used here. We should usually familiar, right? We should make use of this operator as well. Once this is done and exit will happen, as it's a void, right? It doesn't need any, return to it. And this is a pointer. It stores in the respective addresses of the variables. When that is done, we can access the data as result.real and result.imaginary. Result.real and result.imaginary, and returns to 0. So result.real is addition of the real number 1.1 and 3.4. Imaginary part is minus 2.4 and minus 3.2. 1.1 and 3.4 is nothing but 4.5. Minus 2.4 and 3.2 is nothing but 5.6. This is how it gets calculated and it gets assigned. So we understood how a function can be having expects an argument as a structure and returns the structure and expects a pointer as a reference variable to the structure as well. So these are the three different types can be possible and accessed in the C. Now moving to the next one, defining and using of unions. So we should be very careful while using unions and structures. Why? Because we'll see. More specifically, if you want to create unions, right? Unions is a similar to structures also. When you create it, right? The difference is very simple. Structure follows structure keyword. Union follows union keyword. That's it. No much difference. Everything remains same. But what will happen here is structure allocates enough space to store all their members where unions can. This is only the difference it will have. Only hold one member value at a time. It just holds one member at a time. How you can define union? So see, it's similar like structure. Only one difference is union. Previous keyword is structure for struct. For structure, struct keyword you have to use. Now for union keyword you have to use. And the union name is car. Character is character name and init price. This is one way to define union. Another way of define union is same union car. Character name 50, init price, car 1, car 2, and reference variable are car 3. So these are the different three types of unions of union numbers. So union 1, union 2, union 3. Car 1, car 2, car 3 entities, which will have again associated with name and price tag. So name and price, name and price, name and price. Car 1, car 2, and car 3 again. Now int main function is will have the another way is union car. Car is a name of the union car. And these are the different types of car members. Car 1, car 2, and star car 3. Once this is done, you return with 0. These are the different three types of defining the union. If you observe, structure also has the same type. Only change here is instead of union, you will write structure. Instead of structure, you write union if it is union. And members is same, right? And the same thing, structure also follows the same pattern. Here also structure also follows the same pattern. But what is the main difference? Main difference is union hold only one member at a time. How to access members of union? We can use dot operator to access the member of union, and to access the pointer variables, we use this operator. Pointer variable, whenever the pointer variables are there, you use this operator to access the members. One example is, we'll see one classic example for that. Union job. 1 second. Union job. Union job is the name of this union. And it has this three variables that are defining for you this union. One is character array name. The size of it is 32 and float salary. So this float value will be assigned to this variable salary. And next is integer worker number. So we have created alias structure number ujob. Another one is union is completed. Another I am creating a structure here. This structure zone. Same with same variables. Character name array with 32 size and float salary and init worker number and the structure alias name is sjob. Now if you want to see the size of each. So printf size of the union, size of ujob, printf size of the structure, structure sjob, return 0. If you see, right, both I am having the same variables, but for union, if you observe, we are getting 32. For structure, if you observe, we are getting 40. What is the reason? We know character. What is the size of the character? Size of the character is 1 byte. So which is 32. And float is 4 bytes. Integer is 4 bytes. Then what will happen? 4 plus 4, 8. 8 plus 2, 10. Which is 0 here. Now 3 plus 1 is 4. So as a whole, we know once you declare it, structure will hold always this 40. Because all members get allocated only when just variable declarations are enough. But for union, it is not like that. Union will handle only one entity at a time. That means the first entity, whatever it is there, right? 32. Character name. That one only it will handle. Rest 2 it won't handle. So the size, whenever you called it and find out the size of it is only the character name of that. This is the difference I'm highlighting. So if you want a low sized pack of structure, you have to use union in your coding programming. Where it holds very good. Whenever you are processing huge amount of data, at that point of time, you want to access only the first variable of the union. Then you use only union instead of structure. Union takes less allocation. Let's say you are having, here it's a 40 bytes, right? Let's say you are having 1000 bytes to process. At that point of time, you just need only one particular variable, which is name, which is declared in the first. So that name, I just want the name. I just don't want any other thing associated variable. For the faster execution, you use union declaration instead of structure. Because union just focus on one entity of the variable. That's it. Not all the variables. Other variables, until unless you access specifically, it won't consider allocating sizes to it. Next topic is enumeration, which is enum. So in C, an enums is a user-defined data types that consists of set of named integer and constants. They are used to improve code readability and maintainability by assigning meaningful names to the integer values. How we can do it? Enum is a keyword used for enumeration. This enum keyword follows by this enum variable name, enum underscore name. In that, I am accessing 3 variables, which is const1, const2, const3. So if you pass enum and corresponding variables, you no need to tell what is the value associated to it. By default, it will associate ascending order. Start with 0, ends with whatever numbers it is there present inside the size of the enum. So the constant 1 will automatically assign with 0. Constant 2 automatically assign with 1. Constant 3 automatically assign with 2. Let's say you don't want to assign 0 to constant 1. Then you just assign 2 here. and at last 4 here. So 3 will automatically assign to here. This is one way of doing it, or else you just assign const 1 is equal to 3, and rest you don't need to assign anything. Automatically the compiler increment and assign one after other. So it assigns 3, 4, 5. Const 2 is equal to 4, const 3 is equal to 5 values. This is a beauty in enums. So enums are very powerful. If you are having any series data, then you can use enums directly during the series data. One classic example is week. So here in week, if you consider, we know week will have 7 days, Monday to Friday. So Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, and Sunday. So you just tell if you don't need to tell also fine. So enum will default assign with 0 to 6. Or else you want it to be 1. So you just assign m is equal to 1. For m1 to Sunday to 7, it will assign. So this is one classic example for enums. So this is how it works. So enum and day is the name of this enum. And Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Now what will happen is it's a enum, right? By default, Sunday gets 0 and this gets Saturday gets 6. These 7 days. Defaultly, it will assign values. Now int main function. In this int main function, what I'm doing? Enum, the structure number enum, day only. And we have to create short name for this. The short name for this is today. Is equal to Wednesday. If the today is equal to Wednesday, print it's Wednesday. Else it's a return to 0. Exit 0. Okay. What is the benefits of using enums? While using enums, right, we can have these 3 types of benefits. As I said, for readability purpose, if you are having 1,000 or 2,000 employees data, and each employee's IDs gets started series in a series with increment by 1. You no need to assign the number directly, like Harish 1, Suyog 2, Sai 3, like that. You no need to explicitly mention. You just keep them in enum in order based manner. Their IDs gets automatically saved. And how you can access is enum, the short name, dot, employee name, for example, Sai. If you use a printf, it just prints what is the value associated. Let's say the value associated ID number is 87 for Sai. So 87 gets automatically printed. You no need to assign for it. This is very useful, right? Instead of storing every variable, if I want to store this in struct or something, I need to use ID is equal to 87. Like that, you have to use every variable for every entity. Instead of that, you can use enum. So for the readability, instead of using raw integer values, you can use some meaningful names, making your code easier to understand. Next is maintainability. If you need to change the value of a constant, you only need to update in the enumeration definition, enum definition, rather than searching through the entire code base. Let's say in the previous example, right? This starts with 0 and ends with 6. But in convention, let's say this starts with 20. In future, it got changed, requirement got changed. Customer is saying Sunday is 20. Value, assign the value to 20. Now rest all numbers are 21 to 26. So instead of changing every variable like that, you just assign Sunday to 20. Then automatically your code gets updated automatically. You don't need to change any line in the code. This is called maintainability. Next, safety as well. The compiler can check that you are using valid values for the enum type or not. If you are not using valid values for enum type, then it will help you to prevent the errors. It will throw an error, obviously. So These are the benefits for enum. If you use the right enum during your definition of coding, you can save your time, save your memory and allocations, and your versatile code as well. Next one is bit field in structures and bit fields in union. So this is very, very important. And today's last topic, bit field in union and bit field in structure. So first we'll see bit field in structures. What is this bit fields? Bit fields in C allows you to define the structure members that occupy a specific number of bits in larger data types. This is useful when you need to pack data tightly or work with hardware register at the bit level. So you remember, right? Registers. This is mostly used in embedded systems. When you use embedded C coding, right? In that, if you want to hardly work with a register, let's say work with a register binary, it will have 8 bits. 8 bits. If you want to alter a bit, initially here it is 1, you want to change with 0. So what is this? 0, 1, 2, 3. So index 3 of this particular register R1. If you want to change, then it is possible to change this using bit fields in structures as well as bit fields in unions as well. So how to do it? As this is not a memory location, it's a hardware register, right? So register, you remember, right? Register is the keyword that is used to define a data type of a register where it stores this value in the register of a memory hardware. So the format is for structure, struct and structure name, data type, member name, and what is a bit width, and continuous. We'll see one example. So if you see here, right, I am creating a structure and packed data. Unsigned integer. Unsigned integer means integer of data type. So the name of it is flag1. And if you see the colon and 1, unsigned integer flag2, colon and 1, unsigned integer value colon 6. That means this is the updated member for the particular data. How these are using, we will see. Now, in the main function, struct packed data. This is a packed data structure, and we are creating entity for this structure data. For this data, to access the first member, what I will do using dot operator, I can access. It's not a pointer or referenced value, right? So we can use dot operator to access it. So data dot flag1. Flag1 is this. So I assign flag1 is equal to 1, flag2 is equal to 0, value is equal to 20. Then what will happen? If I read it, then what will happen? The size of data is as it is structured, it calculates all the data, right? And how many bytes? 6, 7, 8 bytes gets calculated. But if you understand here, a bitwise operator will have 1, 0, and 20. That means the first bit, and the 6th bit. So this 6th bits gets calculated accordingly. And when you store it, it will store accordingly. This is how you can access the position of a variable. Next one is bit fields in unions. How this can be used in the unions as well. So these bit fields can also be used within unions, allowing you to access the same memory location with different interpretations. Here, one thing you have to understand is it will access the same memory location, but with different interpretations. Let's say we will have our initial storage of data with 6. Now, if the same data storage is having with 10, the 6 value get referenced with 10. This is the advantage of bit fields. One such an example is stdio.h. Union is a data type of union, the keyword. Now, register access is the union name. In that, I am having unsigned int value, one variable name of union. Inside that union will have varied data types, right? Union can handle structure also. This is like union of structures. It's like union of structure. You can have union of structure 1, structure 2, structure 3 also. This is one classic example. That's why I've taken this example. So the structure unsigned integer bit 0, 1. Unsigned integer bit 1 is 1th bit position. Unsigned integer bit 2 to 7 is 6th bit position. So I have 6 bits associated data that can be stored over here. And the structure name is bits. This is the bits. So here bit fields of this structure being present inside the union. Now, if you go to the main function, right, what is happening? Union register access with a short name as reg. This entire members of the union will be associated now with reg. Now, what will happen? Reg dot value is equal to 0x5a. So this value is 0x5a. So init value, this integer values is 0x5a. If you print the value, what will happen? If you print the value, you'll get 5a. And if you want to print bit by bit, then what will happen is, so unsigned bits of it is reg register dot bits, the structure of this dot first member, which is in this structure, the first member is bit 0. Again, second member is bit 1. Third member is bit 2 to 7. This is how you can access one member to another member from union to the structure, and that structure on inside another structure member. And you can use to print what is a value for this corresponding data. Why we have given u is nothing but this is an hexadecimal value. That is the reason we have to print in hexadecimal value u. So here what will happen? The first bit value will be stored in bit 0. Second bit value is stored in bit 1. Third to sixth bit will be stored in bit 2 to 7, because it has 6 bits associated data. That means from 0 to 1, this is 1 bit, 1 bit, and 6 bits. So total 8 bits get stored over entire structure, but with a different naming convention. Bit 0, bit 1, bit 2, 2 to 7. What is the advantage of these bit fields in union? If you remember this, we can access the same memory location with different interpretation. That means here memory location is same, which is 0x5a, right? If you know 8421 code, 5a can be represented as 0101. This is 5. And this a can be represented as, a is nothing but 10, right? 1010. 8 plus 2, 10. So I am minding this. So if you further divide this 5a, which is equal to 5 means 0101. A is 1010. Now, if you read the structure bit 0 should hold 1 byte, 1 bit, bit 1 holds 1 bit, bit 2 holds 6 bits. So how many bits are there here? So here, how many bits are there? 1, 2, 3, 4, 5, 6, 7, 8. 8 bits are there. Now what will happen? So always the addition of attention starts from left hand side to right hand side. So this is LSB. This is MSB. Most significant bit and least significant bit. So bit 0 is assigned and stored with bit 0 variable. So this value stored in bit 1. And this all data, right, mentioned here, this will be stored in bit 2 to 7 variable. 2_7. If you understand it, right, the same address 0x5a data in the same memory location with the different interpretations we are storing, which means this bit 2_7, if you print, you will get only this data. What is this? 01011. This is nothing but 1, 2, 4, 8, and 16. Right? That is nothing but 8 plus 2, 10, 10 plus 1, 11. So when you print bit 2 to 7, you will get 11 as answer. When you print bit 1, you will get 1 as answer. When you print bit 0, 0 is the answer. Initially you are having 5A only, but when you see, right, when you print separately by accessing this particular bit registers, you will get a different value, and each value will have different interpretations of it. As a whole, if you see, it is same like 5A only, but when you see sliced data of this particular registers of bits, you will get 11, 1 and 0. This is a beauty for bit fields in unions, and this is how you will, read and access the data members in the structure. Very important concept when you deal with hardwares. One is bit unions and one is bit structures, bit field structures. In bit field structures also will have the same thing, but union at a time it will hold only the value. If you see, right, for this, it will always hold the first member, which is the value. When you find out UFS, like print of s register access, you will get 0x5A. That's it. But if in the structures, if you see, right, you'll get all this data, which is 1010 0101. This all data gets printed over there. But in there you will get 5A, and it won't have again 1101. It will just have 5A. This data won't be printed because union at a time it will hold only one variable at a time. I hope union and structures are clear. That's all. Thank you for today's class.